Okay class, I'm going to walk you through lesson 2. The topic we're doing is perimeter, area and volume. Hopefully you did your Pythagoras' theorem exercises yesterday. Today we're going to look back over perimeter. Okay, so perimeter, as you should know, is the total length of the outside edges of a shape, or the distance around the outside of a shape. So predominantly we're going to be doing a lot of adding, some calculations, but mostly then adding all those shapes together. For circles, the perimeter, we have a special name for that, which is called the circumference. If you go around something, go around a country, go around the world, circumnavigation, you've heard that name before. So as examples for triangles, for right angle triangles, if you're given these two sides, obviously you can use Pythagoras' theorem to calculate the third side. Just in case you've forgotten how to do that, remember this. In this case, I've got the two smaller sides. That's going to be 2 squared plus 5 squared. And if we square root that answer, it'll give us this one here. So if I was doing that on the calculator, I'd come across 2 squared plus 5 squared. That's our c squared. We'd have to square root that answer. And so this long hypotenuse here is 5.38, not too much longer than this side. So for the perimeter, once I've got that side, all you have to do is go plus 5 plus 2. And so that triangle would have a perimeter of 12.39 or 12.4, correct to one decimal place. For circles, the perimeter of a circle is given by this formula, which you should have seen before. C for circumference equals 2 times pi times the radius, or little r. So if we know the radius of a circle, if we multiply it by 2 and pi, we'll get the distance around the outside. Similarly, if we have the diameter, the whole distance across, it will just be pi times the diameter. If we've got a half circle, now remember this perimeter, the curved bit here is going to be half times 2 times pi times r. And if you look at 2 times a half here, that's going to be equal to 1. So another way to think of this would be pi times r for that curved bit. But don't forget this straight bit here. In this case here, it would be 4 meters. And this 4 meters on this diagram is actually the diameter. So if you're going to do the curved bit here, it would be a half. I'm going to do it the long way. Half times 2 times pi. Now remember, pi, you can get shift this button down the bottom middle, and then times the radius. Now the radius of this circle would be 2 because the diameter there's 4. So the curved bit here would have a length of 6.238, and then to finish off that perimeter, we're going to add the 4 to that. So that shape, half circle there, would have a perimeter of 10, let's say 10.3. For a quadrant, again, this time we've got 3 sides. We've got a curved side and we've got 2 straight sides. We can assume, being a quadrant, that this side here will be the same as this. This will be the radius. So we've got a 3 here and a 3 here. In this case, because it's a quarter circle, this curved bit will be a quarter times 2 times pi times r. 0.25 is the easiest way to put a quarter into your calculator. Times 2 times pi times the radius, which will be, in this case, 3. So that curved bit has a length of 4.7, and then we're going to add 3 and add 3 again, because these two are the straight sides. And so this one here, very similar to this one, except this is millimeters. 10.7 would be the perimeter of the quadrant. For all your composite shapes here, say for shape A here, obviously there's 2 sides that aren't given on the diagram, but look at opposite sides. If this is 10 and this is 6, obviously this one is going to be 4. And if this big one is 8 and this one is 4, obviously this one would have to be 4. Similarly with this one here, I'll just quickly show you how to think about that one there. Well, you've got a 6, a 6, a 1 and a 3. We don't have this one here. How can we figure that out? Well, think there's going to be a right angle triangle here. Think of this shape here. This bit, this side here will be 3 because we've got a 6 and a 3. This side here, we've got a 6 and a 1, so that would be 5. And so the length of this would be, use Pythagoras' theorem, 3 squared plus 5 squared. Gives you 34. Square root that answer to get the length of that side. So that side would have a length of let's say 5.8, and then you can add up all your sides. Similarly, for this type of shape here, you've got a quadrant onto a square, so all of these sides will be 5, and just like we did on the last slide there, you can work out that curved shape. It's going to be 1/4 times 2 times pi times r, where r in this case is that 4. For this type of one here, you've got a triangle and a square, so obviously all these sides here are 8. This side is also 8, and you can use Pythagoras' theorem, 8 squared plus 10 squared, square root that to get this side, and then your perimeter would be 8 plus 8 plus 8 plus 10 plus the mystery side here. And for something like this one here, you've got a circle and then a smaller circle on top of that. So this is 4. So the radius of this half circle here would be 4. So you would do a half times 2 times pi times 4 to get this curve shape. This would be 4. This distance here, now because this is 4, the radius of this circle would be 2. It's a half circle. So again, you could go a half times 2 times pi times that radius, which would be 2. But count how many edges there are before you start, because that's how many things you're going to need to add together. Last example, you've got this square onto a half shape. See if you can do that yourself. Just pause the video and have a crack, and I'll come back with the answer. Okay, hopefully you agree. We've got 5 plus 5 plus 5 plus 5, that's 20, and the curve shape here came out as 7.85, so that would be a total, or a perimeter for that shape, of 27.85 meters in this case, because that's the units. Okay, the exercise 1E, page 21. Please do all the questions. They're reasonably straightforward to start with, but make sure you try some of the composite shapes, similar to this question here. And the textbook, I've attached it to the link on the Google Classroom. Hope you're all going well. If you have any questions, make sure you can email me anytime or ask me on the Classroom. And if I don't hear from you, have a great holiday, and we'll pick everything up next term.